Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today we are going to discuss about enumeration of permutations and combinations. So the overview of presentation includes introduction to permutations and introduction to combinations and enumeration of permutations and combinations. So here in this enumeration of permutations and combinations we have sub-concepts also like permutations when all objects are distinct, combinations without repetitions with examples. So first of all, we are going to discuss about what is meant by permutation, combination, and also we are going to discuss about the permutations when all objects are distinct and also combinations without repetitions. And we are going to understand these concepts along with the examples. So first of all, what is meant by a permutation? So an arrangement in a sequence of elements of a set is called a permutation of elements. So basically here permutation is nothing but the arrangement of any object. So means here the order matters here in which way we are going to arrange it. So let us suppose here a permutation is nothing but an arrangement of some elements in which order matters. In whichever way you are going to arrange it, that is matter here. The order is matter here. So in other words, a permutation is ordered combination of elements. So here from a set, for example, here we are going to understand this permutation along with the example. So from a set x is equal to x comma y comma z, by taking 2 at a time when all permutations are. So here let us suppose here I have taken s is equal to some elements x comma y comma z. So some elements here I have taken. So now I want to select 2 at a time. So that 2 can be anything, but you have to arrange it 2 at a time. So how many possible combinations we have? How many possible ways we have here? So here x, y I can choose. This is one order. And even yx also I can choose here. So why? Because here xy is one order, yx is another order. So you can choose either xy or yx, or even zx you can choose, and even zy you can choose here, or else yx is already done, no? So here yz and zy. So here if you observe here, total how many combinations we have here? xy and here yx, zx, zy, yz and zy. So here zy, not zy here, xz. So if you observe here, what are the combinations we have? How many ways we have here? xy, yx, zx here, xz, zy and yz. Total how many ways we have here? How many ways? In how many ways we can arrange here? Is total 6 ways. So let us suppose here the same question, s is equal to x comma y comma z. Now by taking 3 at a time. So how many possible combinations we have here? So let us suppose here x, y, z. First order is here x, y, z, and here x, z, y is another order here, and here y, x, z is order, and y, z, x is another order here. In the same way here z, x, y, z, y, x. So if you observe here, this is also you will get 6 combinations here. So these are all the combinations that we can have. In how many ways we can arrange it here. So x, y, z, and even here you will get x, z, y, y, x, z, and y, z, x, z, x, y, and z, y, x. So these are the 6 ways we can arrange 3 at a time. Now here we have s is equal to, let us suppose another example, s is equal to 1, 2, 3 form a permutation of 3-digit numbers from a set. Just like how you did here x, y, z by taking 3 at a time. Now we are going to take here for 1, 2, 3 digits, we are going to take 3 at a time. So here 1, 2, 3 is one combination. Next 2, 3, 1 is another combination. So 3, 2, 1 is another combination here. So in the same way 1, 3, 2 and 2, 1, 3, and so here 3, 1, 2. So total how many we have here? 6 possible ways to arrange this 3-digit numbers 3 at a time from 1, 2, 3 numbers. So in the same way if I want to arrange only two numbers at a time. So let us suppose here you will get 1 2 2 1 and 1 3 3 1 2 3 3 2. So altogether here how many chances we have, how many ways we have here is 6 ways we can arrange it here. So this is like here permutation is nothing but here it is an arrangement of the objects or it is an arrangement of the numbers. In whichever order you are going to arrange it, that is matter, means that is the order it matters here. Now let us see the combinations here. What is meant by combination? Combination is a selection or choosing of objects without regard to order or arrangement. Means if you are picking up, if you are selecting two objects or two values or two numbers, so here order doesn't matter. If you are picking up, that is enough. That is only one time you have to select it. Whereas in the permutation, so the order is matter there. If you are taking xy, yx also you have to choose there. So a combination of n objects taken R at a time is called R combination of n objects. So here a combination of n objects you are taking here, taken R at a time, we can call it as R combination of n objects. So it is an unordered selection of n objects, of n objects. So combinations are nothing but what? So here selections where order does not matter. So that is what here permutation means. The order matters where we are going to arrange it. Whereas combination is selecting the values where order does not matter. So let us suppose here we are taking one example. Students for a team. Imagine you have 4 students. Let us suppose 4 students are there. Those are A, B, C, D. Now you want to form a team of 2 students. Here I want to form a team of 2 students. Then how many possible combinations we have here? So let us suppose here AB we can choose, AZ we can choose, AD we can choose. But here I can't select BA. Why? Because I want to form only 2 students. The 2 students can be anything. So whether A or B or B or A, you can choose anything. So AB, AC, AD. Next BC, BD. Next here CD. Here I can't select CA. Why? Because CA is already done. Here I can't select with CB or it is already done. C is already combined with B and CD here I am giving. So now BD and even here you can take AD also. And so that is what here. So AB, AC, AD and here BC, BD and CD. So even AD is also done, right? So here how many combinations we have? 1, 2, 3, 4, 5, 6. Total 6 combinations as we are going to take 2 at a time here. So total combinations are here 6. So here A and B is same team as B and A. That's what here. If you are taking A and B, if you are choosing A and B as one team, then obviously B and A is also same team. So no need to take A and B and BA as this is only selection, not arrangement here. Now let us see here enumeration of permutations. And also we'll see enumeration of combinations in the next slide. So first of all, permutations. In this, the topic are permutations when all objects are distinct. So a permutation of n objects taken R at a time is an arrangement of R of the objects R is less than or equal to n. So here the formula is here, if you are taking n objects taken R at a time, means out of the n objects you are taking some R, it means you are picking up R at a time, that is called an arrangement of R of the objects here. So that is here R is always less than or equal to, means whichever you are picking up from the total n, so always R should be less than or equal to n here. So a permutation of n objects taken R at a time is also called as R permutation or R arrangement. So P of n comma R is equal to, or NPR is equal to n factorial by n minus R factorial. Formula is here, whenever the permutations of all objects are distinct, there should be, we have one formula, that is n factorial by n minus R factorial. Let us suppose here, so previously we have seen what is permutation and we have already seen the general example, theoretical examples like how you will be doing. But if you have what we can say, if you have 3 elements, if you have 3 elements in the set, if you want to pick 2 at a time, okay, that is very easy, you will be getting 6 combinations. Okay, but if you have 100 objects and out of the 100 objects you want to pick 50 at a time, So definitely it will become somewhat lengthy here. So that's why we have the formula here to substitute in that. So this total we'll call it as n, and this picking up elements we can call it as r, which is nothing but the formula is here npr is equal to n factorial by n minus r factorial. So this is the formula we have to apply whenever you are going to arrange some elements. So here let us apply that formula here in this examples. So consider three letters here. Let us suppose here we are considering three letters A comma B comma C. The arrangement of the letters A, B, C taken two at a time are 6. So how you are going to get 6 here? So here they are giving here what is the three letters. Three letters means n is equal to here 3. And the arrangement of the letters A, B, C taken two at a time, which is nothing but here r is equal to 2. So here NPR formula is NPR is equal to n factorial by n minus r factorial, which is nothing but here n value is 3 factorial, and n minus r 3 minus 2 is 1 factorial. So which is nothing but here 3 into 2 into 1 by 1 cancel. 1 will get cancelled, which is nothing but total 6 combinations. So that is actually we did in the last slide itself, but it is without formula we have done. So now that is theoretically we did here. So but here we are applying the formula here, that is n factorial by n minus r factorial, which is nothing but npr, and you are going to get the answer here 6 here. So, and here we have another problem also. There are 24 permutations of ABCD taking 3 at a time. Means total how many permutations, total how many values we are having here? 4. And here taking 3 at a time means 4 factorial by 4 minus 3 is 1 factorial. So, which is nothing but here 4 into 3 into 2 into 1, which is nothing but 24 possible ways we have where we are going to take 3 at a time. So total combinations, how many ways we have here is 24 ways we can arrange it here. So next we have third question. Given A is equal to 1, 2, 3, 4, 5, 6. So here let us suppose we have some elements in set A. What is 1, 2, 3, 4, 5, 6? Find the number of permutations of A. So here permutations of A means here taken 4 at a time, taken 5 at a time, and taken 6 at a time. Means altogether here how many we have? N is equal to 6. And here R value is changing based upon the question here. So first question is R is equal to 4. So we'll get 6p4. So 6p4 is what here? You'll get 320. And taken 5 at a time, n is equal to 6, r is equal to 5. So this is 6p5 here. So okay, 6 factorial by 6 minus 5 factorial, which is nothing but 1 factorial. Then you will get here 720. So in the same way, first one also 6 factorial by 6 minus 4 is 2 factorial. So 2 will get cancelled. Then obviously you will get here 320. Okay. Next here n is equal to 6, r is equal to 6. 6p6 factorial. So which is nothing but 6 factorial by 6 minus 6 here. 0 factorial, which is nothing but 1 here. Then you will get 720 answer. So here r value is changing as the n value is constant here. Now how many 4-digit numbers can be formed out of the digits 1 to 9 if no repetition is allowed? So here 4-digit number. If no repetition is allowed is nothing but what? Obviously the question itself here different values you have. Total here how many 4-digit numbers we have here? 1 to 9 is nothing but n is equal to 9. And how many 4-digit numbers you can form here? So means out of n r is equal to 4. So if r is equal to 4, that is nothing but 9p4. So 9 factorial by 9 minus 4 factorial, which is nothing but 5 factorial. So that is nothing but 9 into 8 into 7 into 6 into 5 factorial by 5 factorial. 5 factorial will get cancelled. Then the leftover answer is here, you will get 3024. So this is the final answer here for 9p4 for this question. Now next question here, how many words of 3 distinct letters can be formed from the letters of the word land? So here 3 distinct letters I need to follow. So that is nothing but r is equal to 3 and here LAND. So that is n is equal to what here? 4. So which is nothing but 4p3, 4 factorial by 4 minus 3, 1 factorial, which is nothing but 24 distinct letters we can follow. Okay. Next, how many ways are there? Sixth question here. How many ways are there to select a first prize winner, second prize winner, and third prize winner from 100 different people who participated in contest? Means you have to find out here how many ways are there to select first, second, third. Means you want to select all the three winners, first, second, third prize winners from how many people? 100 different people. So obviously here n is equal to what? 100. And here how many members you have to select? How many people you have to select? R is equal to 3. So how many ways are there? We have 100 P3 is equal to 100 factorial by 100 minus 3 is what? 97 factorial. So here 100 by 97 factorial. So here 100 into 99 into 98 into 97 factorial by 97 factorial will get cancelled. And the left our answer here, whatever you are getting. For example, here I am getting 970200. So this is the answer. Means these many 970200 ways are there to select 3 members out of 100 members. Now, next question, seventh one, let us see the question. Suppose that there are 8 runners in a race. So, total how many runners are there here? 8 runners. The winner receives a gold medal. Second place finisher receives a silver medal. And the third place finisher receives a bronze medal. Okay, so here how many different ways are there to award these medals if all the possible outcomes of the race can occur and there are no ties? So obviously here you have 8 and you are going to select 3 members. So then you will get 8p3. So here the question is very lengthy, but if you understand the question, it is very easy to understand. So here suppose that there are 8 runners, means altogether you have here 8 runners in a race. So in out of that, winner and first prize and second prize and third prize. So they are asking how many different ways are there to select to award these medals. Obviously 8 out of that 3 members you have to select. 8p3 ways we have. So 8 factorial by 8 minus 3 is what? 5 factorial. So 8 into 7 into 6 into 5 factorial by 5 factorial. So this one will get cancelled. So here 8 7s are 56. 56 into 6 is what here? So 6 6 are 36. 6 5 are 30. 336 you will get. So here we have 336 ways to award these 3 medals. Okay. So this is the answer. So now if you observe here, out of these all problems, always R value is less than or equal to n. Okay. So this is like, these are the problems that we can understand how to solve the problems under permutations. So the next concept is here, combinations without repetitions. So what is meant by this combination without repetition? So here the formula here, even for this also we have the formula C n comma r, the number of combinations of n objects taken r at a time without repetitions. So the formula is here n factorial by n minus r factorial into r factorial. So here you will be writing like this, n factorial by r factorial into n minus r factorial. And we can also write P of n comma r is equal to r factorial into C of n comma r. So r factorial will get cancelled, then you will get n factorial by n minus r, which is nothing but P of n comma r only. So the question here is, let us see the problems here under combinations also. Compute the number of distinct 5-card hands to be drawn from a deck of 52 cards. So the question is here, you have to compute 5 distinct cards. We know that card hands. So which is nothing but here you will be having cards with a deck of 52. So where you will have club, spade, diamond, everything. So spade. So compute the number of 5 distinct card hands. Means you need to pick 5 distinct cards out of 52 cards. Then obviously here n is equal to 52 and r is equal to how many cards you are going to pick it? 5. And the question is here, the formula we know that NCR is equal to n factorial by r factorial into n minus r factorial, which is nothing but here. So you will get 52C5. Okay. So if you have calculator, you can solve it here. You can still calculate and you can write the answer, or otherwise even if you write like this also, that is enough here. Now second question here. Suppose there are 15 red balls, 5 white balls here. Assume that the balls are distinguishable, that a sample of 5 balls is to be selected. So here we have red balls is equal to 15 and white balls is equal to 5. Altogether total we have 20 balls. Now here all are distinguishable. Which means we have to assume that all the balls are distinguishable. And now I want to select a sample of 5 balls. So to be selected here. Now sample of 5 balls means the question is here how many samples of 5 balls are there. So for the first one, obviously you have to select 5 balls from all the balls. From all the balls means total how many we have 20. So 20 C5 is the answer for the first bit, A bit. How many samples we have 5 balls. Means here they did not given any restriction that you have to select these 5 balls from only red balls or only white balls. So then we can consider all the balls as total and you can take it as 20 C5 here. And the second bit is how many samples contain all red balls here. So how many samples contain all red balls means what? Whichever you are going to select 5 balls, of those 5 balls should be all red color only. Then obviously here how many red balls we have here? 15. And how many balls you are going to select it here? 5. So here 15 C5. So this is the answer for A bit and B bit here. Now the next question, how many ways can a team of 5 be chosen from 10 players so as to include both the strongest and weakest player? Include strongest and exclude weakest. Exclude both strongest and weakest players. The question is here, how many ways can a team of 5 be? Means you want to select 5 as a team. From how many players? 10 players. So now here we have the conditions also. What is the next condition? So first one is include both the strongest and weakest player. So here out of this 5 you have to include strongest one and weakest one. Means they are already fixed that here strongest and weakest player are there in the 5 players. So they are already fixed. So now the other 3 you need to select out of from not 10 players. Why? Because in 10 already we have one strongest player and one weakest player. So obviously you'll have other 8. Out of this 8 people you have to select 3 people. Then you will get here 8C3. Next, include strongest and exclude weakest player. So now here I have to include strongest. So here exclude weakest means that weakest player I should not add in the 5 people. So that means one strongest is already there. Other 4 people I need to select from how many here? 8 only. Why? Because strongest and weakest are already fixed here. But this one is I am adding in the 5 people. The second one I am not adding. But you have out of 10 players. So out of these 2, if I remove this, again you'll have 10 only. 10 means 10 minus 2 is what? 8 only. 8C4 here. The answer is 8C4. Now exclude both strongest and weakest player. So whichever the 5 people you are choosing as a team, out of that 5 people, we don't have strongest and weakest players. We are excluding both of them. Then I need to select all the 5 people. But out of what? 8 people. So that is 8C5. So 8C5 you have to choose it here. So this is like here the answer is here. So for the first one this is answer. For the first one 8C3 and second one 8C4 and the third one is 8C5. So like this you can choose here. So here as we have to select 5 people as a team. So out of the 10 players it is already fixed that one strongest and one weakest. So we can't touch them there. So means out of that 10 if you remove 2 people you left over with only 8 people and from that 8 people you have to select the other 3 people as we have already included strongest and weakest in 5 people. The other 3 you need to select. So here we are including strongest and excluding weakest, that's why we are taking 8C4. So and here we are excluding both of them means all the 5 members we have to choose not from the 10 members, from the 8 members. Now how many 5 card hands consist of only hearts? So here we know that hearts will have 13, spade will have 13, diamonds will have 13 or so anything. So how many whatever we have here. So everything will be divided into 13 into 4, 52. Hearts are consists of 13 and you have to pick 5 cards. So which is nothing but 13C5. The answer is 13C5. Now, in how many ways can a committee of 5 be chosen from 9 people here? So, here, total here 9 people are there, and you are going to select here R is equal to 5. That is nothing but 9C5. You have to select. Now, the next question is, in how many ways can a committee of 5 or more can be chosen from 9 people? So, here, if the question is 9, you can write it as 9C5. But still we have more up to what? Up to it can have chances of 9C9 also. So then 9C5, 9C6, 9C7 plus 9C8 plus 9C9. So this is the answer for this question. So try to understand the question, then only we can able to answer it. Here these permutations and combinations are very logical questions. So you have to think it and you have to write which one we have to consider a n value and which one we have to consider r value. So in how many ways can a committee of 5 or more? Means 5 or more are there. So that's why you have to add this 9C6 up to 9C9. Means the possible value of n value you have to add it. Now the next question is, out of 8 gentlemen and 5 ladies, a committee of 5 is to be formed. Find the number of ways in which this can be done so as to include at least 2 ladies. Means here I have to select committee of 5. And in this committee of 5, definitely I should have at least 2 ladies. So here at least is nothing but it can have 2 or more than 2. So that is nothing but if you have 2 ladies here, then obviously here if you have 2 ladies and you will have 3 gents. So how many we have here? 8 plus 5, 13. 8 plus 5, 8 out of 8 gentlemen and 5 ladies. So committee of 5 you have to choose it. So now here 2 ladies, I am going to choose here 2 ladies out of 5C2, 5 people. Okay, into, as we have and here you have to take product rule only. 3 gents, 8C3. Now, another combination also we have at least 2 ladies, means it can be more than 2 ladies also. Then I can take 3 ladies and 2 gents, which is nothing but here 5C3 into 8C2. And even you have 4 ladies and 1 gent also, which is nothing but 5C4 into 8C1. And even you have here 1 lady and 5 ladies and 0 gents, which is nothing but 5C5 into 8C0. So if you add all this, then you will get the final answer here. So whatever you are getting 5C2 to 8C3, 5C3 into 8CT, 5C4 into 8C1, 5C5 into 8C0. So you have to add this answer, whatever you are getting here, add it all this, then you will get the final answer. So this is like you have to solve the problem here. So the question is here, you are going to select committee of 5 people. In that 5 people, there is a condition that you have to take at least 2 ladies. Means at least 2 means you can have maximum of 5 also, as you are going to select 5 members. Okay. So, and you can have 0 gents also. But because the condition is only about ladies, we don't have any condition that at least 1 gen. At least 1 gen if you have here, again you have to choose this condition also. Another condition also you'll have 1 gen, 2 gens, 3 gens, like this also we will have. Okay. So this is like how you need to solve it here, this type of problems under permutations and combinations here. So what we have discussed today is what is meant by a permutation, which is nothing but arrangement, in short we can say. And we have also discussed what is combination, which is nothing but a selection, and where the order doesn't matter in this combination and order matters in permutation. And we have already seen the examples without formulas for permutations and combinations, and we have already seen the enumeration of permutations and combinations with example problems. So by this, we'll end the session for today. Thank you.